Hi everyone, and welcome to our final lecture video for this module. In this video I'm going to talk about air pollution control. And air pollution control is really a result of all the bad effects, things that happen to people, the killer smog episodes that occurred. So after the bad happened, then people are like, okay, we need to fix this. So in order to do that, there needs to be a risk assessment for the air pollution, or the air pollutants. You have to evaluate scientific data and make predictions in an organized manner about the probability of an occurrence, meaning the intrinsic health hazard of a substance and the amount of the substance encountered. So for example, you can calculate the risk assessment of the amount of ozone in the air between the hours of say 4 p.m. and 6 p.m. where you live. You can do this on the EPA's website, that's the Environmental Protection Agency. They can tell you your air quality, and you can actually determine if it's healthy for you to go outside during that time frame. So the Clean Air Act, again, began as a result of the sulfurous, the killer smog episode here in our country. And what happened is the EPA set limits. And this actually was modified many times, but ultimately what you see here is that from 1970, and this example is from 2006, but you can see that carbon monoxide has dropped significantly down to more than half of what it used to be. And then sulfur dioxide has also dropped, which is great that's reducing our acid rain. And actually now acid rain is not a big problem for us in the United States as it is compared to other countries in this world because of our Clean Air Act. And the volatile organic compounds have also been reduced, our nitrogen oxides and our particulate matter. Specifically, the 10 micrometer diameter one has really reduced. You know, we still, a lot of critics still say we need to take into consideration many other components of the pollution, really, but this is a great start. And one of the other legislations that actually has improved our air quality is the catalytic converter requirement. So, and that's your smog check, basically. But if you look at LA air in 1968, it is actually much worse than it is. And this is a 2005 picture, but currently, I know this is an old picture, but still, if you compare these two pictures, it's much worse here. And if you talk to old people, the people who used to live here back in the day, they would describe that you go outside, your eyes would burn, turn red, you get teary eyes, sometimes you have a hard time breathing, and you couldn't see a sign 20 feet away, 15 feet away. And so actually a lot of housewives went out on the streets and started picketing and trying to say we need to change our air quality, we need to do something about this. And some scientists actually got on board as well trying to change this. And one of the famous ones is Jim Pitts. I actually worked with him briefly at UC Irvine, and he was one of the lead researchers on creating the catalytic converter. And he would talk about how he would actually get death threats in the mail, and he would get calls in the mail telling him basically to stop research because it's going to cost industry a lot of money essentially to make this change. And a catalytic converter is basically your diamond ring of the car. It's made out of platinum. It is one of the main metals in the catalytic converter. But basically what happens, you burn the fossil fuel in your car, and out of the exhaust comes your hydrocarbons, right, your volatile organic compounds, your carbon monoxide, your nitrogen oxides. And it reacts with the platinum. It's like a filter. And on the other side, you get out water, carbon dioxide, and nitrogen. So you get out all of the, basically what comes out is things in the air that are not necessarily bad for you. Water and carbon dioxide and nitrogen are naturally in the air anyway, and they're not bad for your health. The thing is that sustainable good changes are seldom made electively, right? And it took a lot of people, a lot of work to make this happen. And ultimately, public policy had to come into play here. It was not an elective decision. Car companies did not decide all of a sudden we're going to put this in all of our cars on their own. People did not go out and buy these all on their own. It had to be put in there by law to make this happen. We did similar things with industry. So here is smokestacks without any types of scrubbers, and this is an electrostatic precipitator. Just the thing you need to know about it is it works like the same thing like a catalytic converter. Basically, it filters out the nasty stuff in the air. So this is what it looks like without. With, it's still burning stuff, but a lot less toxins are coming out. And keep in mind, the catalytic converter and all of these types of scrubbers, they're not 100% efficient. So you're still getting, air pollutants coming out. It's just the quantity coming out of your car or these, refineries, industries, whatever, is much, much less. So part of what the EPA has done is set attainment values. That's basically attainment value is the amount maximum of the air pollutant you should have in your area. And if you look at these U.S. urban areas with the worst air quality, these are ozone non-attainment, meaning they do not get down to the safe amount of ozone, essentially. One of your extreme worst is Los Angeles South Coast Air Basin. Very severe would be Chicago, Houston, Milwaukee, New York City, New Jersey, Southeast Desert of California. And severe would be Baltimore, Philadelphia, Sacramento, San Joaquin Valley, and you see this here? Ventura County. We made it here, you guys, here in CSUCI. We made it into the worst air quality list. This is in 2002. But if you actually go look it up, what really gives us the bad air quality is not, thank God, Camarillo or Oxnard or Ventura, all these regions where we're at, hopefully just Camarillo for you guys, and the worst areas are Ojai and Simi Valley. And you can see why. The air gets blown in from the ocean through this narrow pass, and it gets up into Ojai, and it can't escape out of those mountains. So you have this little valley and all these mountains surrounding it. And not only that, if any of you have been to Ojai and Simi Valley, they're really hot places, sunny and hot. They don't have that fog that we get in Camarillo from the beach. Here it's just sunny and hot. Great places to grow vegetables and fruit and all that. But what do you need for photochemical smog? Heat, sunlight, and of course, exhaust from cars and chemicals in the air, which they get there. And to make it better, you could put it into a valley with, an inversion layer. So these places is what actually got us onto that top list. One last note before we end this lecture is indoor air pollutants. Don't forget about that. We often only think about what's going on outside, but actually your pollutants can be 5 to 100 times greater inside than outdoors. And keep in mind, people also spend 70 to 98% of their time nowadays indoors, and we get some pretty bad air pollutants. If you drive your car into your garage, and actually I'm so strict about this in my house, I don't let anyone park in the garage because I'm a little crazy about chemistry and atmospheric chemistry. But you close the door and you open up the door of the house, and all those nice, exhausts go right into your house. If you cook with a gas stove, If you have glues all over your house, which we do nowadays, right? Particle board. What's this other one called? It's like particle board. Oh, I'm blanking now. But your cleaning supplies, which you might want to be careful. Think about cleaning with like maybe vinegar, baking soda, solvents. Basically, a lot of the stuff that our house is made out of is constantly degassing chemical compounds into the air, and we're breathing it. And we get this thing called the smokestack effect. So essentially, if you're on the second floor, all that air is rising up. And so often the air pollution in the second floor, or third floor, or fourth floor is worse than it is in the first floor. So the moral of the story is it's good to air out your house often. If it's good weather, just open the windows. Try to avoid using cleaning supplies that, or aerosols or anything that could put chemicals into your air and you breathe it in. All right, so that is the end of our lecture on controlling air pollutants. I hope you enjoyed this section. Okay, bye-bye.